Okay. Now, whoever took the stickers last time can have my last prize. No, I'm kidding. All right, this is your speaker evaluation form. Have you been informed of that? Okay, so whatever session you're in, if you like to bitch, this is the tool for doing it. It's yellow, it's in your bag, and you just, mark on here who you liked and who you didn't like. So please do that, because we take that seriously, and I know Dan Kaminsky comes back every year, but look, we eventually listen to you. He's not here now. Okay, so takes us a few years, but we eventually listen. Okay, I think these guys ready? These guys ready? Okay. Okay, these two guys are speaking about VoIP security, which I think is fascinating stuff, as I mentioned earlier. Jason and John, they're from the Midwest. I'm told they have great teeth, and what else? Good shoes? Yeah. Okay. And you don't want to listen to me, so I'm going to get off stage. But anyway, give it up for these guys. I'm excited to hear them. So.
Whoa. Hopefully I won't have mic karma again, right? So my name is John Kindervag. I'm a senior security architect with Vigilar out of Dallas, Texas. And Jason Overbrook is my comrade in arms here. He's a senior security consultant for us at Vigilar in Dallas. And wow, I got a new mic.
Backup. Well,
okay. It's a backup, because this one just died.
The second button from the right up. The second one up from the right. Let's talk about the light. Yeah.
Okay, well the mic died too, so there we go. Can anybody hear me? I'll just have to speak up.
Keep using that podium, yeah.
Okay, well the podium mic just died when you came up here. It didn't like you. Anyway, somebody is hacking the audio system. Can anybody? I swear I touched it not.
Place that one with that one.
Test it, okay. Okay, bear with us, please. Cisco did this, by the way. We're pretty convinced that somebody from Cisco is doing this to try to silence us, to keep our voice from being heard. Hello, keep talking. I'm talking.
Cisco was going to sponsor next year.
Oh, they were, you said. Yeah, they were. Sorry about that. Hello, 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 hello.
Just speak up.
Okay. Well, I've got one person telling me to do one thing.
Just go. Go on.
Okay, we're going to go on.
We're going to work on it.
So we're out of Dallas, Texas. We flew in here yesterday, so we're excited to be here in D.C. About a year ago, we were in the D.C. area taking a class together, spent a week out here, and through the discussions that we were having, we came up with what you're seeing today. The ideas and the tool and all that stuff really started here in D.C., so it's fun to be back here. So I'm going to tell you what we're going to talk about today. We're going to talk a little bit about security in the converged network, why corporations and enterprises and everybody's all excited about voice over IP and why that concerns us as security folks. We'll talk a little bit about the business risks, some of the attack stuff. We're going to demo the VoIP Hopper tool and show you why we think there's some real problems in voice over IP networks today, which is the real reason for all this stuff, okay? So the idea here is Jason and I have been working together for many, many years, and one of the things that we've done a lot of is assessments, and we've started to do more and more voice over IP assessments. And every company that we go in thinks that their voice over IP network is phenomenally secured. And we're going to show you a little bit later on why we think that's not a true statement, but the passivity of the enterprise about the security issues in voice over IP has been something that's been concerning us. And Jason, as our lead security consultant, has toasted many, many voice over IP networks. And the problem is that from an enterprise perspective, if you're a CIO or an IT director, you're excited about this concept of convergence, that we can put all different types of information, voice, data, video, all on the same pipe and reduce our costs, make moves, adds, and change easier, all that kind of stuff. We're going to have less cable, right? Because now instead of running two cables, one for the phone and one for the for the computer, we can just plug the computer into the phone, and wow, that saves us a lot of cabling costs, time, all that kind of stuff. That phone is a computer, so it has DHCP, so if I need to move offices, I don't have to get my telecom guys and do all kinds of stuff. I just plug it in, it gets an address, and boom, my moves, adds, and changes are highly reduced. Theoretically, because I'm on voice over IP and I'm on a network, a lot of my toll charges are gone, so that's part of my TCO. And hey, I can get voicemail in my inbox. How cool is that? I mean, that is a huge driver in a lot of corporations. I can get voicemail in my inbox. I don't know how valuable that is, but it's a big selling point. And so at the end of that whole list of convergence and why people are deploying voice over IP technologies becomes security. And it's an afterthought. And in fact, it's so much of an afterthought that even today, companies that we work with that we've shown insecurities in their network related to voice over IP still believe their voice over IP networks are secure because the manufacturers say they are. And we're trying to create more awareness within all people, the general public, people who do network security or IT administrators, and say, hey, there's some real things you need to be concerned about. So we've discovered that there is a phenomenally low awareness as to the security threats of voice over IP. This audience is probably a little bit different, but a lot of audiences that we talk to, and certainly corporations we talk to, think, oh, there's no way. Voice over IP, that's fine, it's great. And so what we have discovered, what we're going to demonstrate is a special kind of attack or a proof of concept related to publicly accessible IP phones. Because you go into an organization that has IP telephony deployed, you're going to see phones like this. This is a Cisco phone, but we're vendor agnostic. I will say Jason, I'll give him all the credit here in terms of the genius behind this. But Jason has broken Avaya phones, Nortel phones, Cisco phones, we don't care. Voice over IP. That thing is available in a lobby, in a waiting room of a hotel. It's in hospitals, all kinds of places, conference rooms. And folks like you can come in and plug your laptop into that or into its cable, and you can have access to the corporate data without any problem. That's what we're going to demonstrate. So through the tool that Jason created and the concepts that were put into place to develop the tool, we've determined that we can gain privileged access through the voice network into the data network, and that, in our opinion, is a significant threat to the enterprise. So if you look at how networks are deployed from an IP telephony perspective, you create a separate VLAN called the voice VLAN that's different from all your other VLANs, which are, for the purposes of this presentation, just called the generic data VLAN. And that voice VLAN, the idea is that's going to keep voice traffic only on that VLAN, and there's not going to be any data traffic on it. And the idea is that this is going to be secure, right? Because how many people think VLANs are a great security measure? If I said that in the corporate world, most people would raise their hands. VLANs, they're secure, right? So that's one misunderstanding that a lot of people have. Secondly, by putting all your voice traffic on a single VLAN, you can control the quality of service. You can get better quality voice calls, and it allows the IP phones to auto-configure. So the phones will easily associate to a logically separate VLAN. They're designed to be very, very simple. And they also allow the simultaneous access of a regular PC into the phone. So the back of this is a switch port. There's a switch, a regular 10100 switch, and you can plug a computer or a laptop right into it. And that's both good from an IT administrator side and bad from a security perspective, because as Jason's going to show you or talk about, that allows us to bypass a lot of controls. So this is what it generally looks like. There's a voice VLAN in green here that terminates at the phone, and there's a data VLAN that bypasses the phone and goes into the computer. So the idea is, hey, it's really simple to deploy, easy to cable. IT administrators love it because it makes their job easier, and it truly does. My background is as a Cisco networking guy, and I've been involved in a lot of IP telephony deployments, and you can just scan the barcode on that and deploy the phone, and bam, you're done. It's much easier. But from a security perspective, there's some real concerns here. So we started doing these voice over IP assessments, and people would say things like, well, you can't access our corporate data from the IP phones. So we started doing voice over IP vulnerability assessments and controls validations, and we discovered that we were able to gain administrative access to servers in the data center through the phone. So we did a security focus article where we kind of detailed it a little bit, where we could go into a hotel that had voice over IP, plug into the hotel phone, and get into their corporate network and record the phone calls of the president, for example, get into their accounting system, all that kind of stuff, through a network that was supposed to be logically separated and secure from their corporate network. So these physically isolated locations where these phones are, everybody thinks they're secure, but you're not watching them. If somebody's in their hotel room, they have access to that, you can't be watching them, and that's a pretty big concern. So this is the tool. This is a screenshot. It's available on SourceForge, and you'll see that later. This is a new version done just for Shmoocon. We showed the version 1 at TorCon last year, and this is a brand new version that Jason's been working on for the past few weeks to demonstrate specifically to you. So I'm going to turn it over to Jason Ostrom, author of VoIP.
What up? I'm Jason. Give me here.
That doesn't work, so you just have to speak loud.
So I'm going to show you something that I haven't shown anyone before, something I'm really passionate about. The genesis of this tool, VoIP, that I wrote. In essence, this tool is just basically it tags an Ethernet frame header, the voice VLAN ID, and does a VLAN hop. So it's basically a VLAN security test tool customized to a VoIP environment. And so what we're looking at here is in a typical customer scenario, what I normally work with is customers that they have like a back-end trunk, and this is specific to remote IP phone deployments, like in lobbies, anywhere where there's low physical security, and there's a back-end network trunk into the internal network, and network administrators aren't thinking about, well, what happens if a PC is disconnected, or the phone is disconnected from the network, and the PC is directly connected, and then the PC tags its Ethernet frame header to get access. And a lot of customers are not even doing the proper filtering like a firewall at these remote locations. So once you're a phone, you have full access to the network, and that's what we found here. Like I said, we're tagging the Ethernet frame header, and there's some stuff that we're doing in the beginning for the voice VLAN discovery. We're really attacking the network infrastructure, the device discovery protocol that's used, CDP, and then we're going to talk about Avaya. I'm going to have to go through this really quick. This is really about attacking the network infrastructure security. I want to be clear on what this is. Poor network design. It's not about exploiting Cisco Unified Communication Manager or exploiting the Avaya platform. These are the specific threats that I see. Once a PC gets access into the voice VLAN, there's never a good reason for that to happen, in my mind. And so you can do denial of service against the IP phones. That's trivial. There's myriad tools out there to do that. If the firewall is properly implemented, there's going to be certain ports that have to be open in order for the IP phones to talk to the PBX, and you can always attack those signaling ports all day long once you have access to the voice VLAN. The third thing, and this is the most critical, is if they don't have a firewall between the voice VLAN protecting from the rest of the network, then you've got full access into the internal customer network. And actually sitting on an internal customer network, most customers trust the internal users that they're not going to VLAN hop into that IP phone network. But really, what you can do is you can plug your laptop in the back of the phone and get access into the voice VLAN and just cause the denial of service so the phone network doesn't even work. Okay, here's my demo. We're going to go through this real quick. I got a Catalyst 3560 Power over Ethernet switch. I've got the Backtrack Linux distribution running on an attacker laptop, and I've got a Cisco Unified IP phone. The voice VLAN is 200. The PC VLAN is 100, and you can denote the IP addressing there. Okay, let's jump into the demo here. Okay, the first function of VoIP is if you're a network administrator, you can easily just test the VLAN security if you already know the VVID, the voice VLAN ID. So we're going to go, let's see, make sure on our Ethernet interface. for its E0. So we go VoIP hopper, specify the interface, and then the VLAN ID I already know is 200 since I'm a network administrator. So there we go. We're in the voice VLAN. We got 200.0 network. So we see, let's do an IF config. And we see that we have the newly created voice VLAN interface. So VoIP hopper is in the voice VLAN right now. Now, one new feature that I did for this presentation is I created a where you could, basically a feature where you could delete the voice VLAN interface, so you can easily test this and you can script in between this. So all day long I can create the new interface and then delete it, okay? So another new feature of VoIP hopper is I can do a MAC address spoofing where offline, so we can take the MAC address of the PC right now and we can change the MAC address. Like if I don't want to connect to the Ethernet port before I've spoofed the MAC address, then I can just do this. So I don't want to spoof the phone's MAC address because I'll get disconnected from the network here. So anyways, we see that VoIP hopper complains that it's the same MAC address. Okay, now jumping on to Avaya DHCP discovery. So let's take a look at Avaya. The flag for Avaya is, let me check this. Okay, this is the Avaya flag, and I'm going to show what it does here. All right, so we see here what's going on here. Let's take a look at this. Basically, in an Avaya environment, there's a special DHCP coded client that VoIP hopper has to send, and the DHCP server is provisioned for that. Right here we see. So this is my DHCP server configuration here. And basically, the fascinating thing about this, and I think it's really an elegant solution, is Avaya has it configured where this custom DHCP client is sent. It requests the option 55 in the parameter request list, and then the DHCP server responds back with 200. I could show a packet sniff on that, but I'm running out of time on this, so I'm just going to skip over that. But I will say that my favorite gem uses Avaya IP telephony, and I'm really fascinated about going in there and doing like a social engineering where I can pretend like I'm the phone, custom repair guy. But I think I'd be thrown off by the cute girls in the gym, so it's always nice when I'm the only person in the room that finds something amusing. Let's talk a little bit about Cisco here. Let's jump into that world. This guy right here, we were working on a 802.1x bypass. And basically, this is the new feature of VoIP hopper. Cisco, basically, 802.1x enabled ports along with voice VLAN feature, you can bypass that via CDP. So let's go ahead and plug that in and do this really quick here.
You got 40 minutes or 30 minutes.
Okay. So the phone, I'm going to plug into port 2. And we're going to run actually a capture here as well. We've been disconnected here. Okay, so now we see here that the switch has recognized the IP phone, and it's now operational on the port. Now I'm completely locked out of the attack machine. You can't see anything because we've got. Let's take a look at this port configuration. Okay, this is the 802.1x configuration. We have port control auto right here, that's for 802.1x, and I'm only allowing, I also have MAC address filtering enabled. I'm only allowing the MAC address of the IP phone. So I'm going to go ahead and run this right now. Let's actually show, I'm guessing here that the IP phone is 200.2. Okay, that is. So the IP phone's connected, I can ping the IP phone. Let's disconnect the IP phone. Let's plug in VoIP hopper, PC.
VoIP Hopper is part of Backtrack 3 too. It's
Look at
being
that.
compiled on that.
Ports configured is now operational. VoIP Hopper is only connected. See, we have the phone totally disconnected from the network, and okay.
How is it seeing the device history?
How is it seeing what? Go ahead.
The device history, why it recognizes the system of the line?
Because, okay, so what we're doing here with VoIP Hopper is using the tool to emulate how each phone works. So Jason's gone in and figured out how each phone works. Cisco phones use CDP to connect. Cisco Discovery Protocol, Avaya phones use a flag-in DHCP. So we've got emulation of both different phone sets.
Okay. So yeah, I can ping the phone now. I mean, not the phone. I can ping the PC. So I've broken into the voice VLAN. Thank you. Thank you.
There's a question in the back, Jason.
Well, we need to go.
Here?
Yeah, sure. What's the question?
So some Cisco phones, like the 7940, send their own CDP on the switch,
Right.
announcing themselves.
Right.
Have you found that useful?
I'm sorry?
Have you found it?
Have you found that useful in any way?
Well, yeah, that's what I'm doing. I'm spoofing the 2 CDP packets. I'm going to show you guys later on. I'm going to actually show it.
You're probably I understood that you were catching the one emitted by the switch, announcing the VoIP field.
No, that's not what I was doing. I actually sent the CDP packets just like the IP phone did. That's how I was able to gain access into
the
voice.
old version of VoIP.
I'm sorry?
I was thinking of the old version of VoIP.
Correct. This is the brand new version that does CDP spoofing. I'm going to show both of the versions. Excuse me. Okay, I'll jump into that. So we've demonstrated this. We need to get back into the PC. Okay, so the next thing I started thinking about, I realized I was making kind of a mistake when I was doing this pen test with the customer because I was always disconnecting the phone from the wall and I would connect the PC directly in. And I was like, started thinking, what happens if I plug into the back of the phone and do some fun sniffing on the back of the phone? So that's what I'm going to do right now. I'm going to plug the phone in, and then we're going to go into the back of port 2 on the phone. Okay, so this connection, I'm SSHing into the regular data access VLAN on the Backtrack machine, and we are we're going to sniff on the back. That's what happens when you have nervous fingers. Don't worry, it's a fake password. Be real careful now. Okay, let's go ahead. This is I'm going to use the libpcap, and this is what VoIP Hopper uses. It uses libpcap, but I'm going to use tshark. I've got this filter expression that I'm using, and we're sniffing on the back right now. Okay, so I specify the interface. And now this is the new feature of VoIP Hopper. You've done -C is for CDP. There's 2 different modes. There's sniff mode and then there's spoof mode. We're going to do sniff mode right now. Okay, so we're sniffing on the back of the IP phone. And the fascinating thing is, in a default configuration, these Cisco IP phones actually advertise CDP, and they actually send and receive CDP.
On the PC.
I'm sorry?
On the PC port?
Yes.
Yes, on port 2, on the PC port, by default, Cisco IP phones send CDP and they receive CDP. What's that?
He said it was fascinating.
Yeah,
That makes perfect sense. That's just a switch, right?
Yeah.
And it's a broadcast packet. So it just goes on both ports, right?
No, it sends its own CDP. It's functioning as the Ethernet switch. It's not getting sent through from the switch to it. If you analyze the CDP, okay, so we see here VoIP Hopper got its IP address. voice VLAN 200. If I was to run a packet capture right now, you would see that the CDP packet is generated by the IP phone and sent to the PC. It's not sent from the Ethernet switch through the phone. Okay?
So Cisco, after the release of the first VoIP popper, built some functionality into some of their iOS code to defeat some of the things we were doing.
I'll talk about that.
Okay.
Did that new feature. Okay, now I want to show you the CDP spoofing. All right, so this is the brand new feature. I've got it set up so that it shows the example usage for a SCCP firmware phone, as well as here we go here. All right, so we see here that VoIP popper sent one spoof packet and sent the second spoof packet, and it got its IP address. And you see here that it's sleeping and sending CD packets after that. Every 60 seconds, which is exactly what an IP phone does, and I created some custom code so it sent the VoIP VLAN request. You see here 512, that's the VoIP VLAN request from VoIP popper. 200 is immediate response from the IP phone or the switch. Okay? So I couldn't believe that when I saw that, because that has a lot of security issues right there. So let's take a look at this. How do we mitigate this? Well, in SCCP firmware, you can disable the PC voice VLAN access. That will turn off CDP, so the phone doesn't respond or send CDP. And then it only allows the VLAN 100. The second way to mitigate is disable the PC port on the back of the phone, so there's no access on PC port 2. Okay? This is a URL by Cisco that's some interesting recommendations. I'll get into that in a second here. That's some good time.
Yeah, you got time.
Okay.
Calm down.
All right, so we see that it sent its other little discovery packet. Because what happens is on the 802.1x, there's an aging mechanism of 3 minutes on CDP, and I could show it here, but after 3 minutes, if VoIP popper doesn't send that packet, then the switch removes it from the CDP table, and the port goes inoperational. So VoIP popper has to keep on sending the CDP, and I mean, to me, CDP obviously is not a security mechanism. So we've just kind of coded a little CDP client into VoIP popper. All right. So what happens when a customer goes ahead and disables all those PC ports? So there's a real fancy hack that I've learned, and it's called unplugging the phone from the back of the wall and plugging the PC directly in.
Can you go over that again?
I'll post it online for you. So when the PC is directly connected into the wall, which is in the low physical security areas where you can get away with doing that, some of the administrators I've talked to, they say, well, it's easy. We're going to defeat this voice VLAN access by just doing MAC address filtering, right, John? You've seen many customers do that. So let me show you another fancy hack.
Does everybody in the room know you can spoof a MAC address, right? Just wanted to check. Okay, thank you. You work for one of my clients, don't you?
We're in trouble here.
Oh, okay. Well, that makes sense.
Okay. So the crazy trick is you look on the back of the phone and it has its MAC address printed on it. Call me.
Doesn't it even have it as a barcode?
Yeah. It's
Well, I mean, I'm going to talk a second.
Extra speed uses a barcode.
right. Yeah, it's designed so you can scan it for deployment, right? Convergence, what I mentioned earlier, but that gives us a lot of tools to get into it.
Okay, so I've got the MAC address right here on the phone. I'm just going to show a quick example of this.
But if port is disabled, can you use your hub, plug the phone into hub, and then your PC in the same hub, and then?
Absolutely, yeah. And I was going to talk about that, but you beat me to the track. Going back to these lobby phone recommendations is really good. This is a really good URL by Cisco, posting all this good information on these remote IP phone deployments. And one of the things they say actually is removing the sticker off of here, and also locking the display phone settings, so you can't find the MAC address. But I've got a slide on that. I mean, it's just all you do is just put a hub in between, and you can sniff for the MAC address. So if it's a physically insecure location, you're going to find the MAC address. Okay, that's a given.
forget the power supply because your hub's not going to do PoE for the phone.
Okay, so, that was a mistake I made. What I wanted to show here was I spoofed the MAC address and, oh good, I didn't do that there, okay. So I do -M, and that's going to spoof the MAC address kind of on the fly, so VoIP proper will do it before. But what we want to do is we want to do this -D flag, and the -D flag will say don't spoof the MAC address of the default interface, only spoof the MAC address of the newly created voice interface. I have to fix some of this DHCP code here. Okay, the interface is already created. All right, so we see here, it didn't spoof up here, but it did spoof the MAC address of the newly created interface, okay? So VoIP proper has access right now, and if I was to go, we see here that we're sourcing our interface from the voice interface. Okay, so what are the implications of this? This gets into the fascinating part here, is Cisco has a brand new feature in iOS 12.236 SE, April 2006. And it's really fascinated me. Let's take a look at it. Detect Cisco phone, okay? So this little feature here basically uses IEEE 802.AF, basically line power. And once I just turn it on here, it uses basically CDP and Power over Ethernet to, so you have to have line power, entry in the switch, and then you have to send CDP. So I've been testing this a lot voraciously in my lab, and I can get it to where I can connect VoIP popper PC to the switch port, and it doesn't air disable, it doesn't shut down. But when I send CDP, the switch immediately air disables the port because it's getting the CDP packets and it doesn't have a Power over Ethernet entry on the switch port, which to me is pretty interesting.
Is that enabled by default?
No, it's a brand new feature, and it's in, like I said, 12.236 SE, which is April 2007. And this is the feature right here. So let's.
There's been a similar feature in the past we've encountered with someone connecting a bridge, where it auto-detected across the bridge that there was a IP phone on the other side of the bridge and started broadcasting across the bridge, which connected back and ended up basically saturating the entire network and shutting down every phone call in the organization.
Huh.
That'd probably be, is that related to UDLD or something like that, where you're keeping state of the other side of the bridge?
Okay. Now look,
Yeah, okay.
I just spoofed CDP, and you see here that we have a CDP to text message on the switch. It didn't like my CDP message because I was connected and I did not have Power over Ethernet, so we immediately go into air disable state. That's pretty slick if you ask me, that feature. But we're just going to see here in a second. So this gentleman over here stole my slide. I was talking about hiding and filtering the MAC address, and we already talked about the physical security of the IP phone switch port is crucial. Okay, so phone CDP security, we talked about that. Port goes in air disable. I showed how the port got shut down. Sometimes if an IP phone's connected and you immediately connect, you unplug the phone, immediately connect the PC, it'll immediately go into air disable, which is pretty cool. Okay, so it can be bypassed in a couple scenarios here, phone CDP security. The first scenario is with only phone CDP security enabled, you can plug into the PC port on the IP phone and run VoIP popper like I demonstrated before. So we run the CDP spoofing, and I'm using basically the phone as my Power over Ethernet Ethernet adapter on the PC. So that's the first scenario. So what we're saying here is phone CDP security alone is not, you shouldn't rely on it. It's like the layered approach. Scenario 2 is the customer has disabled the PC port on their IP phones and phone CDP security is enabled. When MAC address filtering is not implemented, you can bring a rogue IP phone into an environment that allows the PC port 2, and you can use that to gain access into the voice VLAN. So I've done that in a couple of security tests for customers on their internal network. I bring in my own IP phone, and I'm able to enumerate information about the network and do some fun stuff. Okay. So
You have a question?
Yeah, are there phones you can just change the MAC on?
What's that?
Can you change the MAC on?
Not the.
Well, if the phone is set up so that they've disabled the second port on that particular phone, what he's saying is he can bring his own phone in, right? Yeah.
Yeah, he's talking about changing the new MAC address.
Right, right, yeah.
I don't know how to. I haven't really studied that, so I don't know. I think it's kind of burned in. I don't know. It seems like you'd have to mess with the firmware. I haven't really looked at that. But anyways, this is in my testing. This is the perfect scenario for remote phone deployment right now. You turn on phone CDP security. You do MAC address filtering to only allow the one MAC address of the phone, and you disable the PC port or the voice VLAN access. And then right now, I can't get into that. So that's something that's going to help you out.
Just plug a device in front of your attack machine and get it to 11 a.m.
Right, exactly, and that's what I'm looking for. I'm looking to get a Ethernet card for Linux that supports Power over Ethernet, and then then VoIP Hopper is already coded to support that.
Would you need a card to support Power over Ethernet, or could you have like a custom cable that just Power over Ethernet?
Splice off the 4 wires that are going to the power. The phone can think that it's configuring and it's sending all its information by the power. It's just cutting off its 4 data ports. And I mean, it's not the most elegant solution, but if you have a cable that does that.
Yeah, that'd be great. You want to email me about that? See, I just plugged in the phone, and it's booting up here. Oh, the port's down because of the PC.
So a lot of the things that you have to do to defeat VoIP hopper or any VLAN hopping attack breaks the concept of convergence in the enterprise. So all the benefits of voice over IP kind of go away, and now you've just got an expensive phone.
Okay, so the phone's up now. It's device detected. See, this is the line entry that you have to have. The switch has got to detect on the switch port, has to detect some type of power Ethernet signal. Then you can spoof the CDP. And obviously, it used the CDP message to find that it was a 7940 phone. Okay, so we're getting at the end here. I'm looking for Ethernet card supporting Power over Ethernet or something with the cable. So
Can I throw a Shmoocon the guy said something about the cable? That won't work. Ethernet 3A power does not use the unused pairs. It uses 1 and 2, 1, 2, 3, and 6, just like M100 Ethernet does. So you couldn't just splice off like the brown pair.
Okay.
Put resist the other side.
All right. Well, the research I've been doing, there's like chipsets, like Texas Instruments has
Yeah, I
some.
would love to find like a little hub that is like a inline power.
Yeah. So
You can get an injector too.
Don't speak AF. They speak pre-standard
They
Cisco
speak
stuff,
AF
which I think
now, though.
is unused pair.
No, it's not.
You sure?
I'm sure. Yeah, I got
Okay.
3524 running access points over 2 pairs, so.
Yeah, the 3524s do. They speak both.
3524 are not Ethernet 3A system protocol.
Okay.
In case of a software-based platform, whether running on PC, whether it creates a virtual interface and there are also 2 VLANs, so how does it work?
No, I haven't really messed around with the soft phones. I don't know at this point. So.
They're not VLAN.
I don't think that the soft phones use it because it's tied into the Ethernet IP of the actual laptop. So, I mean, if you could create a virtual interface on a laptop and run the soft phone through it, then I'm not really concerned about that. Right now, it's the IP, the hard phones right now. So we fixed the DHCP code. In the future, there's a new DHCP option for Avaya that I need to code. There's an Alcatel DHCP option, and then I'm going to start doing like trunk port encapsulation on VoIP Hopper.
Do you do Nortel DHCP requests?
No, I don't do Nortel right. I haven't done Nortel yet, so I'm looking to get
Should be very succinct.
Nortel into my lab. So Here's some information here. I mean, if you want to email me, that would be great. The VoIP Hopper SourceForge page, it's also included in Backtrack. There's a URL for the security focus article, and this is our contact information. And I've got one more slide here since we've got.
Can you go
Back up.
Yeah.
What's VoIP Hopper written on?
See.
That's yours. No, I put yours under there.
You guys do very many, I do a lot of pen testing, and I find a lot of times our really dumb customers have their voice over IP gateways exposed to the internet.
Yeah.
You do a lot of remote attacks on these.
Yeah, I mean, I'm really interested in that, but I used to work for one of those providers that has those VoIP gateways, and it's crazy the security you see. I know, it's crazy. So if everyone's seen that, I'm going to go to my last slide here, which is just a little story here. There was a Cisco Summit blog, and some guys got offended that we said that Alcatel was slightly superior because the device discovery, because it's easier to sniff for CDP than it is to send a custom DHCP request. So some guys that really love Cisco called us VoIP hacker clowns. Yeah, so I mean you can go read about it. It's pretty funny. And then the typical reaction from a Cisco drone, blah blah blah. But anyway, so I never had a hacker handle, and so I was thinking VoIP hacker clowns. I was going to turn that into VHC. that was going to be my new hacker handle. John and I, the VoIP hacker clowns.
There we go.
That's all I got.
Can you go back to your contact?
Yeah.
So if you ever want hate mail, do something that makes Cisco look a little bit bad.
Yeah, and also on the SourceForge page is my personal email address, so you can contact me off of my Vigilor email address.
We got like 5 minutes. Any questions? Any schmooballs? I don't even have a schmooball.
Just in your conversation
Thank you.
with your customers about this, I'm just curious if any of them say anything about why their voice network would be like less Apple than their data net. It seems like you could really just crank down on that and only get into a couple of boxes. Why is it so open?
You want to answer that? I want to make sure I understand. Can you repeat again?
Of why, if you give your voice VLAN, it obviously only have to get to a handful of servers. Why aren't people, firewalling this off better?
So why are voice VLANs so insecure ultimately, right? And the reason is because they're a VLAN, and most IT administrators think of a VLAN as a security tool, right? So they don't think about it. I mean, it's just such an afterthought, security and voice over IP deployments, that people might worry about a call manager getting a virus, but they're not worried about this kind of stuff. How are people getting into that? Because they're generally not hackers, right? They're people who are just trying to do availability. Make sure that the boss can get dial tone. This is all about dial tone, and dial tone and security have never gone very well together. So a lot of the guys who came out of the Telcon group, and when they got rid of their Meridian phone and they put in IP telephony, those guys didn't know anything better, right? So, and then they're isolated in their own world, and so we're just trying to educate them and say, consider that there might be some security holes in voice over IP.
Any other questions?
Thank you.
Hey, sorry if I get a lot of trouble. I'm sorry. I was afraid that we weren't going to get through. Oh, thanks.
Yeah, or an injector. We can probably do it with an injector, but this came out so early.
Hey, do you have